Anyway, let me welcome Dr. Scott Holmes. He's the chair of Cryogenic Electronics and Quantum Information Processing International Focus Team for the International Roadmap for Devices and Systems. And he also plays an important role in our Discover project, working directly with the PI of the project and University of Southern California. He's been very active in DARPA project, and then earlier it was Air Force and other federal, and then also in the industry. Dr. Holmes received his bachelor degree from MIT and graduate degrees from University of Wisconsin at Madison. Okay, so Scott, it's all yours. I think we have quite a nice crowd now. Let me see how. Yeah, we've already have like 20 people. I believe we can start. Let's say, well, we can wait maybe one more minute because people chip in. And again, this is the first seminar in this semester, and the next seminars will come, as always, on Tuesdays, first Tuesdays of the month at 3 p.m. Eastern Time, noontime, West Coast, California time. So I will try to, if any of you has any suggestion of an interesting speaker, please let me know, and I will be trying to do my best to incorporate your wishes. I will actually very much welcome any suggestions of interesting speakers who could contribute to this seminar series. Okay.
Okay, well, I think I'll just start with a comment that this is going to be an overview. It's intended as an overview, and I'm covering a lot of material. And if your favorite material is not in here, it's not because it's not important. It's because I had so many things to cover. There's a lot of stuff to do in this area. So, can I get started?
Yes.
Okay. So I'm going to be talking about in general a technology roadmaps. Where do we need to go and when and that sort of thing. Let's see. Oops. I do have an abstract and information in the presentation that is already, let's see, that was already in the flyer, but that's for reference. I'm going to be talking a little bit about motivations, more about superconductor electronics, and most about superconductor electronics, then a little bit at the end about quantum information processing. So why are we doing this? Well, there was a time, this was about 10 years ago, when we were even over 10 years ago, when I was supporting the government. We were looking at some problems with just the amount of energy usage that's going into computing. And even then, it was clear that the amount of energy was just getting huge. And the number of solutions, for instance, this data center that Facebook was building in Luleå, Sweden, there weren't a lot of places like this where you get some free cooling, and they have a river with excess hydropower, and it looked challenging. That situation has not really changed. Now, it's not so much Facebook these days. It's AI, machine learning, things that are gobbling up the power. But it continues to be a serious problem. So, yeah, we got a problem. And at that time, it looked as though superconductor computing was promising, and we were able to sell a program, so-called the C3 program, cryogenic computing complexity that on paper looked like, could have some significant benefits, especially in power and size. And the big problem that we had with that program was memory, and memory continues to be a problem. So the need is still there. Solutions are still waiting.